Something strange is happening in the asteroid belt. One particular asteroid, once thought to be just another silent chunk of space rock, is now vibrating, subtly but persistently, as if it's alive. Telescopes from around the world have picked up these rhythmic pulses, too regular to be random, too deliberate to ignore. Some scientists think it could be a natural phenomenon, like thermal stress or seismic activity triggered by internal ice. But others aren't so sure. The vibrations almost seem patterned, as if the asteroid is trying to communicate, responding to something we haven't yet understood. Could it be a new kind of geological behavior, a remnant of alien technology, or something far more profound? A form of cosmic life we've never encountered? In this video, we'll explore how this asteroid's strange behavior was discovered, what the leading theories say about its mysterious vibrations, why some scientists are starting to question everything we know about asteroids, and whether this could be the first sign of life unlike anything on Earth. The asteroid in question is officially known as 1998 KY26. A small, fast-spinning body located in the inner region of the asteroid belt between Mars and Jupiter. Measuring just about 30 meters in diameter, it was first discovered over 2 decades ago and at first glance seemed entirely unremarkable. Just another spinning rock among millions. But what sets KY26 apart is its rotation speed. It completes a full spin every 10.7 minutes, making it one of the fastest rotating asteroids ever observed. That alone intrigued astronomers. Then, in a recent observation campaign using the Hayabusa 2 spacecraft and ground-based radio telescopes, something even more bizarre emerged: consistent micro-vibrations pulsing across its surface. These weren't the random tremors we sometimes detect in icy bodies. They were patterned, rhythmic, almost like a heartbeat. Scientists double-checked their instruments, suspecting interference or mechanical error, but the results kept coming back the same. KY26 was shaking, ever so slightly, in a manner we've never seen before. What's more, these pulses didn't match any known geological process. For an object so small and lacking the gravitational heft to maintain internal heating, this kind of sustained motion just doesn't make sense. Nothing in our historical data, from the earliest asteroid discoveries in the 1800s to modern high-resolution space scans, has ever shown a small asteroid behaving like this. KY26 may be writing its own chapter in the cosmic playbook, and we might be witnessing the first clues to something entirely new in our understanding of the universe. So, what exactly is going on inside asteroid 1998 KY26? To understand that, we need to take a closer look at what could possibly make a solid rock in space start to vibrate, especially one so small and fast-spinning. Normally, asteroids this size are considered rubble piles, loose collections of rock held together by weak gravity. They don't have molten cores or tectonic plates like Earth, so they shouldn't be capable of generating internal motion. But KY26 is different. The rhythmic tremors detected by both the Hayabusa 2 spacecraft and Earth-based radar systems suggest there's an energy source, something dynamic happening beneath its surface. One possibility is thermal fracturing. Because KY26 rotates so quickly, parts of its surface heat up and cool down in minutes. This extreme temperature cycling might cause internal cracks to expand and contract rapidly, creating a kind of seismic hum. But here's where things get weird. Thermal fracturing usually creates random, chaotic vibrations. In KY26, the tremors form repeating patterns, like tapping fingers on a table, not crashing waves. Another theory involves piezoelectric effects. On Earth, some minerals generate electric currents when they're stressed or compressed. If KY26 is rich in quartz-like materials and is undergoing internal stress, maybe from a recent impact or ancient cosmic collision, it could be converting that stress into a low-level electrical pulse, which then causes micro-vibrations. Still, that's speculative. We've never confirmed such a process on an asteroid before. And then there's the truly strange idea: resonance. Some researchers suggest that KY-26 may be resonating, vibrating in response to an external force, perhaps a gravitational interaction with another object or even solar radiation pressure. The vibrations could be a byproduct of the asteroid adjusting to its environment, like a bell ringing when struck by invisible hands. To dig deeper, scientists have started scanning KY-26 using radio telescopes like the Very Large Array in New Mexico, and even monitoring for gravitational anomalies using data from the ESA's Gaia Observatory. So far, nothing definitive has emerged. But the consistency of the pattern and the lack of a natural explanation has left experts both puzzled and intrigued. If this asteroid is sending out a signal, intentionally or not, we need to keep listening. So when can we expect something dramatic to happen with KY-26, if anything at all? The truth is, in astronomy, timing is rarely immediate. Objects in space evolve over thousands or even millions of years. But in this case, scientists are considering the possibility that whatever is causing KY-26's vibrations might already be part of a slow-building process. If the asteroid is internally unstable, perhaps from accumulated stress, a hidden ice pocket, or even a dormant reaction, then it could rupture suddenly. Some speculate it may fragment without warning, or worse, explode from within like a mini supernova of rocky debris. But there's another layer of complexity: time delay. KY-26 is located about 1.6 million kilometers from Earth, which means we're observing its behavior in near real time, unlike stars that are light years away, where we see events long after they've occurred. That makes this even more fascinating. Any sudden shift or explosion on KY-26 could be witnessed almost instantly, live as it unfolds, not centuries after the fact. If something dramatic does happen, like a structural collapse or an energetic outburst, it could produce a brief but brilliant flash, possibly visible even with backyard telescopes. In an extreme case, it might scatter its material into a reflective cloud, creating a temporary spectacle that rivals the brightness of Venus in our night sky. Whatever happens, one thing is clear: KY-26 has our full attention, and we might be closer than ever to witnessing a cosmic event unfold in real time. Imagine stepping outside on a quiet evening, expecting the usual pinpricks of stars, only to see a dazzling flare burst into view near the constellation of Taurus. A light not twinkling like a star, but steady, radiant, almost unnaturally bright. If asteroid KY-26 were to explode, even on a modest scale, it could momentarily outshine everything else in that region of the sky. The debris cloud, reflecting sunlight, might expand like a halo, visible to the naked eye for days or even weeks. For a short time, it could become a new object in our night sky, an unfamiliar guest floating among familiar constellations. In more extreme scenarios, if the explosion were forceful enough, the brightness could rival that of the full moon, casting pale shadows even at night. People across continents might look up in awe and wonder what just changed. Cameras would capture it. Telescopes would scramble to focus. Social media would ignite with questions and theories. It would be one of the rare moments when the entire world collectively looks up, united in curiosity and amazement. Events like this are rare, so rare that many civilizations have come and gone without witnessing one. For our generation, such a cosmic spectacle would be more than just a scientific event. It would be a reminder of how alive the universe is, how unpredictable, and how connected we are to the vastness above us. The strange case of KY-26 isn't just a curiosity, it's a potential goldmine for science. If this asteroid truly ruptures or explodes, it could offer a front-row seat to a kind of cosmic behavior we've never documented in real time. Even though KY-26 is small compared to stars like Antares or VY Canis Majoris, the process it might reveal like internal stress fractures, volatile reactions, or mineral resonance, could reshape how we understand the evolution of minor bodies in our solar system. It could even hint at new physics operating on a microcosmic scale. And if such an explosion were to occur, it might scatter not just rock and dust, but trace amounts of rare, heavy elements. You see, in the universe, most of the gold, platinum, and uranium we treasure on Earth was born in violent cosmic events, supernovae, neutron star collisions, and yes, possibly even cataclysmic asteroid detonations. These events are the universe's recycling plants, taking the raw ingredients of creation and hurling them across space to seed new planets, new stars, and eventually, life. Every atom in our bodies, every molecule of calcium in our bones, every bit of iron in our blood, originated in some ancient explosion like the one KY-26 may be preparing for. When we study these events, we're really studying ourselves, tracing our origins back to the stars. That's the deeper meaning behind all this. In watching KY-26, we're not just chasing a mystery. We're connecting with the universe's grand story and rediscovering our own place within it. Despite how dramatic all of this sounds, there's no danger to Earth from KY-26. It's far too small and far enough away to pose any real threat. Even if it were to explode, the fragments would dissipate harmlessly in space. There's no risk of debris raining down on us and certainly no asteroid apocalypse in the making. What we might see are harmless and beautiful side effects, like temporary increases in atmospheric ionization or faint auroral displays, especially near the poles, triggered by high-energy particles interacting with Earth's magnetic field. What's even more fascinating is that we might get a heads-up before anything visible happens. Thanks to sensitive neutrino detectors buried deep beneath Earth's surface, scientists can catch a whisper of cosmic change before light ever reaches us. These ghostly particles move faster than photons through space and can act as an early warning system, a global scientific alert that something extraordinary is about to unfold in the sky. So, while KY-26 may stir our curiosity and imagination, we can rest easy knowing it's not a threat, just a messenger of the universe's mysterious and magnificent power. We may be witnessing something extraordinary, a subtle tremor in the vast silence of space, the possible final breath of a tiny cosmic traveler. KY-26, barely 30 meters wide, may seem insignificant against the backdrop of supergiants and black holes. But in its strange vibrations, in its quiet defiance of expectation, it reminds us that the universe hides its greatest wonders in the most unlikely places. This could be a farewell millions of years in the making, an echo of ancient collisions, pressure, and time finally rising to the surface. Moments like this invite us to pause, to consider the vastness of what surrounds us. Light that travels, millions of kilometers, particles that whisper of distant events, objects that rotate and hum with energies we're only beginning to understand. Every observation is a window into a deeper story, one that began long before we arrived and will continue long after we're gone. So, the next time you step outside and glance up at the stars, remember that even the smallest object may be carrying an ancient secret. The cosmos is alive with motion, transformation, and mystery. And perhaps, just perhaps, KY-26 is calling to us, not in words, but in vibration. A gentle, trembling reminder that we're part of something much greater. Keep watching the skies. If you found this story fascinating, don't forget to like, subscribe, and share your thoughts in the comments below. We'd love to hear what you think about the mysteries hidden in our cosmos.